Okay, in this video we're going to look at something called tree diagrams to solve probability problems. And we're going to start with an example that we've looked at before. Example number 1 says, what's the probability of flipping a coin twice and getting heads at least one time? So we've solved this problem before. In fact, it's a fairly straightforward problem to solve if you draw a sample space. So the sample space in this case, I'm flipping a coin twice. I could get heads the first time and heads the second time. Heads on the first flip, heads on the second flip. I could get heads on the first flip and tails on the second flip. I could get tails and then heads, or I could get tails and tails. And that's a total of 4 outcomes. And if I'm interested in the probability of getting heads at least once, then I want to know, well, how many ways are there that I could get heads at least once? And that would be that outcome, and that outcome. So I've got 3 ways that I could get heads at least once. So my probability then would be 3 times out of 4. 4 is my total number of outcomes. 3 is the number of ways that I could get heads at least once. So my probability would be 3/4 or 0.75. Well, if I set up this problem using a tree diagram, then it would look like this. This first, it looks like kind of a little sideways V. These are the first 2 branches in our problem, first few branches in our tree. And this basically represents our first event. That is to say, this represents our first coin flip. All right? And in my first coin flip, I know I've got 2 possible outcomes. If I flip a coin one time, 2 possible outcomes. I've got heads and I've got tails. And I also know the probability of each one of these outcomes. It's going to be 1/2 or 0.5 for each of these 2 outcomes. So the probability of getting heads is 0.5 and the probability of getting tails is 0.5. So this is how I would represent this particular event using a tree diagram. That is to say, flipping a coin, the 2 possible outcomes, and then I write their probabilities there underneath. Okay, so now what I want to do is I want to go on and put on another set of branches on my tree to indicate my second event, which is just going to be my second coin flip. And the way I'm going to draw that is I'm just going to add on to these 2 branches here. I'm going to put 2 more branches here and 2 more branches here. And since now I'm talking about my second coin flip, well, I can see that after I've flipped my coin the first time, let's say I get heads on my first flip. Well, when I flip it the second time, again I've got 2 possible outcomes for my second flip. I could again get heads, or I could get tails. And again, I know what the probability is of getting heads or tails. It's still going to be 0.5. So I write that probability here on each one of my branches. And I'm going to do the same thing down here. If I do my first coin flip and I get tails, well then when I do my second one, I've got 2 possible outcomes for my second flip. I could get heads, or I could get tails. And again, I write the probabilities in here. The probability of getting heads on this second flip is 0.5. The probability of getting tails on the second flip is also 0.5. And now I can actually calculate the probabilities of each one of these 4 outcomes. And notice I've got a total of 4 outcomes because at the end of my tree over here, I've got 1, 2, 3, 4 end points. And the way I calculate the probability of each one of these is I just multiply the probabilities going along each set of branches. So for this first set of outcomes here, if I get heads on the first flip and heads on the second flip, well, the probability of that happening is going to be 0.5 times 0.5, which equals 0.25. So 0.5 times 0.5 equals 0.25. So I've got a 0.25 chance, a 1/4 chance, a 1/4 probability of getting heads on the first flip and heads on the second flip. I also have a 0.5 times 0.5 probability of getting heads and then tails. Heads on the first flip, tails on the second flip. So 0.5 times 0.5, again, equals 0.25. And you can see that each one of these probabilities is going to be 0.25 because it's always going to be 0.5 times 0.5. And this one, getting tails first and getting tails on the second flip, that's also going to be 0.5 times 0.5, which is 0.25. And notice that if I add up all of the probabilities of my 4 outcomes, then I would just get 1. In other words, the probabilities of all of my possible outcomes, it has to add up to 1 because that's all of the outcomes that I have. And if I wanted to calculate the probability of getting at least one, of getting heads at least once, well then I would just find which one of these 4 sets of branches gives me heads at least once. Well, this is heads and then heads, so that one does. This is heads and tails, so that gives me heads at least once. This is tails and then heads, so this one gives me heads at least once. And this one is tails and tails, so this one doesn't. So I just add up these 3 probabilities, 0.25 plus 0.25 plus 0.25, and I get 0.75, which is the same probability that I got over here. Well, again, you may be asking yourself, why would I want to use this more complicated method when I can do it so easily here? And it's because very often, as in, for example, the second example here, it turns out it's sometimes not so easy to do it directly. It's not so easy to do it just with a very quick and easy way. So let's take a look at example number 2 here. It says you're one of the goalies on your soccer team and are hoping you will get to play goalie in today's game, but there are other goalies on the team as well, and sometimes the coaches choose one of them to be goalie. You'd like to know the probability that you will be chosen to be goalie for today's game. And you've already gathered some data about the these different probabilities. So you know if Sam is the coach, then the probability of you being goalie is 0.5. You know if Coach Alex is the coach, then the probability of you being goalie is 0.3. And you also know that Sam is coach about 6 of every 10 games for a probability of 0.6. So let's take a look at how we would solve this problem using a tree diagram. So first, I've got my first set of branches here, and this represents my first event. And my first event in this case is who is the coach? And I know I've got 2 different coaches. Coach is either going to be Sam or Alex. That's the 2 outcomes for this particular event, who's going to be the coach. And I also know the probabilities that each one of these 2 people are going to be coach, because I'm told that right here. Sam is coach about 6 out of every 10 games. So the probability that Sam is going to be coach is 0.6. So I want to put that probability right here. Well, if the probability of Sam being coach is 0.6, well then the probability of Alex being the coach must be 0.4, because those probabilities have to add up to 1. So Sam probability is 0.6. For Alex to be the coach, that's a probability of 0.4. Okay, so that takes care of my first set of branches here. Now, the second event that I want to look at also is going to have 2 branches. And my second event is going to be, let me write this as a question here, who is the goalie? That is, who's going to be chosen goalie by each one of these 2 different coaches. So I'm told here if Sam is the coach, that's this first branch here in my first event. If Sam is the coach, then the probability of me being selected goalie is 0.5. Okay, so my outcomes here are going to be me, that is either I'm going to be selected goalie or let's say not me. So if Sam is the coach, the probability of me being goalie is 0.5. Okay, so there's my probability there. If Sam is the coach, then I have a 0.5 chance of being selected goalie. And then that means there's also going to be a 0.5 chance of someone else, someone who's not me, being selected goalie. All right? Now let's look at the probabilities of me being goalie if Alex is the coach. Well, if Alex is the coach, the probability of me being goalie is 0.3. So, okay, again, my outcomes are me and not me. If Alex is the coach, the probability of me being goalie is 0.3, which means that the probability of me not being goalie, if Alex is the coach, must be 0.7, because again, these have to add up to 1. Okay, well now I can do the same thing that I did in my coin flipping example, which is I can now figure out the probabilities of each of these 4 outcomes. That is, if Sam is the coach, this is the probability of me being goalie when Sam is the coach. So I'm going to multiply these 2 probabilities here. 0.6 times 0.5. So 0.6 times 0.5, which is 0.30. And this is the probability that I am the goalie if Sam is the coach. All right? So now let's look at this branch here. Sam is the coach, and someone else besides me is the goalie. So that's going to be 0.6 times 0.5. That's 0.30. Let's look at this branch here. If Alex is the coach and I am selected goalie, the probability of that happening is going to be 0.4 times 0.3. So 0.4 times 0.3, and that's going to be 0.12. And then finally, Alex is the coach and someone else is selected goalie, so that's 0.4 times 0.7. 0.4 times 0.7, and that's going to be 0.28. All right, now, so just to check here, all of these probabilities, these are all the possible outcomes for my situation here, which means that all of these probabilities should add up to 1. So let's see if they do. 2, that's 10. 4, 7, 8, 9, 10. Yes, they do. So all these probabilities add up to 1. Well, so now the question is, what is the probability of me being goalie? Well, let's see. Which of these 4 probabilities represent me being goalie? Let's see. Well, this one right here does, because this is me being goalie if Sam is coach. That's the probability of me being goalie when Sam is coach. And let's see, not this one. This one right here also represents probability of me being goalie. This is me being goalie when Alex is the coach. And then this one again is not. So these 2 probabilities right here represent probabilities of me being goalie, this one when Sam is coach, this one when Alex is coach. So I just add these 2 probabilities together to find the probability of me being goalie. And I get 0.30 plus 0.12, which is 0.42. And that is the probability that I will be the goalie in today's game. Now you have an example on the back of your notes that I want you to try on your own, and we will take a look at this example in class.